Welcome. This is a quick video to go over how to collect the data for our isotope and average atomic mass lab activity. When you open up the document, this is what it looks like. I'm going to scroll down for you. You can see there's the pre-lab definitions, the hypothesis statements that you want to circle one. We'll be going over that in class. And then you get to the procedures. In the procedures, there's the link where we're going to collect the data. I'm going to go ahead and click on that and go over to the screen now. And as you work through the rest of the lab, the directions are there. You can follow through with them and it'll tell you which data to take. Let me go ahead and scroll through the rest of the lab document. That's what the website looks like. When we head in there, we'll see that. Here's the first data table. You'll be collecting information on hydrogen's isotopes. In data table 2, you're going to choose any other element that the program offers and collect data on those isotopes. And then in data table 3, you're going to be flipping over to the other side of the program. I'll share that with you when we're in the website. You'll be collecting information on hydrogen again, but this time focusing on the percent abundance and its effect on average atomic mass. So a different set of data that you'll be collecting for data table 3. And then finally, at the end of the document is the analysis section where you'll be answering some questions. And then finally, the conclusion at the end. Okay. So I'm going to go back up to that website at the top of the procedures. There we go. That's the one I'm going to head into now. When you do, and you head into that website, this is the screen that's going to come up. You have a choice between isotopes and mixtures. You're going to do both. We're going to head into isotopes first. That's the information for data tables 1 and 2. And then data table 3 will be on the mixture side. So you click on isotopes. When you come in there, you'll see a hydrogen atom sitting on a scale. So if we can actually take a hydrogen atom and weigh it out, this is what it's going to look like. On the scale itself, you can see you have a choice between mass number and atomic mass. You could toggle between the two. You'll need both in your data tables. Remember, the mass number is a whole number. You round that average atomic mass up to the nearest whole number because it describes how many, a count of how many protons and neutrons that you have. And since we can't have a partial neutron or a partial proton, that's the whole number. The atomic mass in atomic mass units is the actual weight that you get with decimals and all of that good stuff when you stick the atom on the scale, sort of say. Right? So you have a choice between both, and you'll need both. Up in the top left corner, you'll see that there's a chart showing you how many protons and neutrons are in this atom. So for right now, there's 1 proton in the center. There are no neutrons there. And there's 1 electron. Now, they don't show the electrons, and we don't really need to worry about them for this lab. We're not collecting data on the electrons, but they're sharing with you what would be there if this were a neutral atom. On the right-hand side, we have the piece of the periodic table. It's the first 2 rows of the periodic table, and these are all of the elements that are available in this simulation. So we're going to be collecting data on hydrogen in data table 1, and then you could choose from any of these other atoms that they have listed here for data table 2. I'm going to hit this plus sign, and that's going to pull down the symbol that you would see for this particular element. This is the isotope symbol. The number at the top is your mass number. The number at the bottom is your number of protons. They're showing both. And then underneath there, you have the abundance in nature, which you also have to open up. And you can see they're showing you the percent abundance of this particular isotope. So for hydrogen 1, its abundance in nature is 99.9885%. So most of the hydrogen in the world is hydrogen 1. You'll be collecting all of this data. So in your data table, let me open it up for us really quickly. You could see in data table 1, I need to collect the number of neutrons. It's actually listed there for me already. The symbol, the abundance in nature, the mass number, the atomic mass or atomic mass units. Is it stable? And then a ratio of neutrons to protons. So let's take a look again at all of that information. We have the isotope itself, so hydrogen 1. We have the symbol over here, so a hydrogen with a 1 in the top left corner, or if you want to write H-1, that's fine. I know it's difficult to do exponents in Word documents, so either is fine. You're going to write down the percentage again, 99.9885 is your percent abundance. The atomic mass is on the scale, that's the 1.00783 AMUs. Flip over to the mass number, that's 1. The number of protons is up here in the left-hand corner, there's 1. The number of neutrons is 0. And then finally, the piece that we didn't talk about is stability. So right now, the atom is stable, the nucleus is stable, and they're telling us, hey, it's stable. I'm going to write that down. And then the last column is ratio of neutrons to protons. So right now, my ratio is 0 to 1, right? There's 0 neutrons and 1 proton, and you'd write that in the table as well. Then you're going to move to the next isotope. And the way I do that is by adding neutrons, right? Because it's the different neutrons that make isotopes different. It's still hydrogen, so that 1 red proton there is going to stay the same. But I could take neutrons out of this bucket, and I can add them to the atom. So I added 1 neutron to my hydrogen, and now it's become hydrogen 2. You could see it's still stable. So you could go through and record all of this information. So hydrogen 2, the symbol, the abundance in nature now is 0.0115%. So again, this one is very small abundance. Notice that the mass number is 2. If you were to look up the average atomic mass of hydrogen on the periodic table, it's 1.007, I believe. So really close to 1, which makes sense, right? Because that first isotope, hydrogen 1, was hugely abundant, 99%, and this one's at 0.01. So clearly not as big, and therefore the average atomic mass is closer to 1, not 2. So you could see that it all works out and makes sense there. The average atomic mass, you could click over, and then up in the left-hand corner now we have 1 proton and 1 neutron. The ratio is 1 to 1. So I've collected all of my data for hydrogen 2, and then finally I need to do hydrogen 3. So I'm going to add 1 more neutron, stick it in the center of the atom, and now it has become unstable. Notice that when something's unstable, over here the abundance in nature is sometimes 0, or in this case they're saying there's only trace amounts. The reason why is the instability makes the nucleus fall apart. They're radioactive. They don't last very long. In this particular case, looks like you're still able to get a mass. Sometimes when things are unstable, let's add another neutron just for giggles. Now, this one, it doesn't appear anywhere in nature, right? It's so unstable. If you even attempted to put this together in a lab, it wouldn't last very long, which is why it's showing that there's 0% in nature. So this atom doesn't exist. This isotope doesn't exist. And now my atomic mass is showing up as dashes, and my mass number is still telling me, hey, if I rounded this and I wanted to know how many protons and neutrons are there, there's a total of 4, right? There's still 1 proton and now 3 neutrons, so 1 plus 3 is 4. So you could still get the mass number because that's just a count, how many subatomic particles you have. But the atomic mass, when I put it on a scale, it doesn't register anything because it doesn't last enough to do it. Right? As soon as you make this atom, it falls right apart. So you may encounter this depending on which other atom you choose in the periodic table for data table 2. Once you get to the unstable isotope, it may appear with no number there, simply because it doesn't exist very long or at all in order to get the weight. Let's take that 1 neutron back out. This was hydrogen 3. So again, the final piece of data table 1, you would collect all of the same data, the symbol, the percent abundance in nature, the atomic mass, the mass number. It is officially unstable. You can see it shaking, and the ratio is 2 to 1, 2 neutrons for every 1 proton. The larger that ratio gets, the more unstable the atom is going to be. Right? And that is it. So once you're done with hydrogen, you collect all of that data in your data table 3, you choose another atom and you go for it. So I'm just going to click on beryllium just for fun. You can see once you have beryllium pop up, this is beryllium 9. And you want to go through and fill in the data table until you get to a beryllium isotope that's unstable. You can even pull a neutron away if you'd like. So I'm starting at beryllium 9. I could pull a neutron away and see if I have an isotope a little bit lower. Sometimes you do. In this case, this one is unstable. So beryllium 8 doesn't exist. There's 0% of it in nature. The atomic mass isn't going to register. If you want to start with that one, you can. If you want to start with the first stable one, that's fine too. Right? And then you want to keep adding neutrons. So I would record all of the data. If this were my choice, I'd record all of the data for beryllium 9. Beryllium 10 is already unstable. So once you hit the first unstable one, you collect that data and then you're done. So for beryllium, you would only have 2 rows filled. For something like oxygen, oxygen 16 is stable, oxygen 17 is stable, oxygen 18 is stable, and then it's when you get to oxygen 19 that it starts to fall apart. So for something like oxygen, you would have 4 rows filled in, 16, 17, 18, and 19, the first unstable one, and then that's where you stop. So as soon as you hit that first unstable one, you could stop there, collect that data, and end. The data table that you're putting this in, data table 2, has a lot of rows there. You only need to fill in as many as is necessary for whatever atom that you choose. Okay. That's the first half of the lab. That's data table 1 and data table 2. In the second half of the lab, you're going to go into the mixtures piece. And in this side, you're going to, again, talk about hydrogen 1 and hydrogen 2, and you're going to add in however many they ask you to do. So if you go to data table 3, it'll tell you, okay, put in 5 purple and 5 green, collect your data. Put in 10 purple and 10 green, collect your data. So I could put in 2 purple ones, let's say, and I'm going to put in 2 green ones. Okay, so now I have 2 hydrogen 1s and 2 hydrogen 2s. I'm going to record the percent composition. So right now I have an equal amount of both. So I have 50% purple and 50% green. So 50% hydrogen 1, 50% hydrogen 2. And the average atomic mass, therefore, is right in the middle because there's 50%. Right? So on data table 3, you're recording the percent composition for each isotope and then the average atomic mass. Notice what happens if I keep adding green ones. Right? Look at what happens to that average atomic mass, right? The percent abundance, the higher the percent abundance, the closer the average atomic mass is going to be to that particular isotope. If I start adding purple ones in there, the average atomic mass is going to start moving back towards 1, right? Because again, the higher the percentage, the closer the average atomic mass is going to be to that particular isotope. But you're going to work your way through the chart. It's going to tell you how many of each atom to put in there, and then you record percent composition, average atomic mass. You're going to get to a point in the chart where there's more. They're, for instance, asking you to put in 50 purples and 50 green or 100 green. So once you get past to the amount that are available in the bucket, you could switch over to the toggle view here. In the toggle view, you could scroll over all the way up to 100 for each of the isotopes. So if they want to do 50, you could get to 50 on one side and, you know, maybe 100 on the other, whatever they're asking you to do. But you could flip over to the toggle piece to get all the way up to 100 for each of the isotopes. Right? And again, for data table 3, you're recording percent composition, average atomic mass. Once you're done with that, you're done with collecting your data. You could go back to your worksheet and finish your analysis and conclusions. If you need any help with anything or have any questions, please just let me know.